Hey guys, welcome to the worked answers for the 2019 Level 2 Algebra paper. Let's get into it. So question 1a, we've been asked to solve each of the following equations. The first one here is 3x squared minus 6 equals 7x. So we've got 3x squared minus 6 equals 7x, and this is a quadratic, so we're going to bring everything to one side. We're going to say 3x squared minus 7x minus 6 equals 0. And at this point, you could just use the quadratic solver on your calculator. Let's do it the long way. We'll say our a term is greater than 1. It's 3, so we're going to multiply a by c. So 3 times 6 is... this is negative 6, is negative 18. So we're looking for two numbers that multiply to negative 18 and two numbers, the same two numbers that add to the b term, which is negative 7. Those two numbers are negative 9 and positive 2. So it's going to be 3x squared. Now we split the b term. Negative 9x plus 2x minus 6 equals 0. And you'll notice here, we've just changed the negative 7, split it into two parts, so you haven't actually altered the equation in any way. So now we draw our line, factorise the left-hand side. We've got 3x as a common factor, and x plus 3. On the right, plus 2 as a common factor, and x plus 3. And you know you're on the right track when those two sets of brackets are the same. So now it becomes 3x plus 2 and x plus 3 equals 0. And so we've got x equals negative 2 over 3, or negative 3 here. Sorry, not negative 3. Mistake. So we're looking at negative 3 inside the brackets. So we've got minus 3, minus 3, minus 3, and so this makes our answer for x as positive 3. Okay, small mistake there. Anyways, correct solutions, x equals negative 2 over 3 or 3 gets you the achieved grade here. Once again, you could just use the quadratic solver on your calculator and you'd still get full marks. So our second equation here, 3 over x squared plus 4 over x equals 5. We've got 3 over x squared plus 4 over x, and that equals 5. And there's a number of ways you could do this. You could cross multiply, but then you'd have x cubed as your denominator. You'd have to do some factorizing to get rid of it. I want to multiply it through by x here. So we're going to multiply the whole equation by x. Okay. So we've got 3x over x squared plus 4x over x, and this equals 5x. So we can simplify here, and we end up with 3 over x plus 4 equals 5x. Just combining the left-hand side into one fraction. We've got an invisible 1 here, so we can cross multiply. So multiply diagonally and multiply the denominators. We end up with 3 plus 4x over x equals 5x. And at this point we will bring our denominator to the right-hand side, so we divide by multiply by x on both sides. So we end up with 3 plus 4x equals 5x squared. So we bring everything to one side. Let's bring everything to the right hand side just to keep our x squared term as positive. So it's 5x squared minus 4x minus 3. And at this point we will use our quadratic solver. So mode number 5 for equation, number 3 for quadratic. Our A term is 5, B term is -4, and C term is -3. And so we get values of x equals 1.27 and -0.47. Grades for this question, correct solutions gets you an achieved. Okay, let's move on to question 1b now. So a drug is used to reduce the level of cholesterol in the blood for a daily dose of the drug. The cholesterol level C in the blood T months after taking the first dose must be modelled by the function C equals 0.02 t squared minus 0.6 t plus k, where k is the initial cholesterol level and the function is valid for the first 15 months only. It says a person with an initial cholesterol level of 9.18 is given the drug. How long will it take the person's cholesterol level to reduce to 5.05? Okay, so we've got this equation here. C equals 0.02 t squared minus 0.6 t plus k. We've got 3 variables here. What are our variables? Well, C is the cholesterol level C. So cholesterol level. How do I spell this? Roll. T is T months, so that's basically time in months. And K, it says, is the initial cholesterol level. So, initial cholesterol. Okay. So we've got 3 variables here. It's asking us to find how long it will take. So we're solving for T, and we've actually been given values for C and K. So C equals, it says initial, no, that's K. It says 5.05. We're looking for the time when the person's cholesterol level is reduced to 5.05. And K, it says initial cholesterol level is 9.81. So we can substitute these values into our equation here. We've got C equals 5.05 and K equals 9.81, and we're trying to find T. So we've got 5.05 equals 0.02 t squared minus 0.6 t plus 9.18. Okay. Now let's bring everything to one side. We can say 0 equals 0.02 t squared minus 0.6 t, and then 9.18 minus 5.05 we can calculate, and that equals 4.13. At this point, let's use our calculator to solve the quadratic. So a value of 0.02, b is negative 0.6, and c is 4.13. And so our values for t are 19.3 and 10.7. Now we're not quite done. We have to always bring it back to the context of the question. And we've got two values for C where the person's cholesterol level is reduced to 5.05. But it says the function is valid for the first 15 months only. So they wouldn't put this in the question if it didn't have some relevance. And here, if the function is valid for the first 15 months only, we can say our interval for t is going to be less than 15 and presumably greater than 0. And so that means one of our values for t obviously is not valid, so t does not equal 19.3, and therefore only answer t equals 10.7 here. Okay, correct answer, t equals 10.7 months gets you a merit, and your achieved quadratic equation set equal to 0. So this step here will get you an achieved. Okay, moving on to question 1c now. It says the polynomial p of x equals 2m minus 1 times x squared plus m plus 1x plus m minus 4 can be written as a perfect square. And we've been asked to find the value of m, so p of x equals, and we've got this equation here, 2m minus 1 x squared plus, not x, but m plus 1 times x plus m minus 4. Okay, we've been asked to find the value of m. Now, the key to this question is, and they've put it in bold for you as well, the equation, or the polynomial, can be written as a perfect square. And so when that is the case, basically factoring this, putting it in factorized form, and so if you think about, let's just say like a normal quadratic, ax squared plus bx plus c, obviously we've got some sort of longer terms for a and b and c. It's these 2m minus 1, m plus 1, and m minus 4. But we're still in expanded form here. If we were to factorize, we'd come out with two sets of brackets, and that would be a factorized form. But if we're saying that this polynomial can be written as a perfect square, then that means the factorized form in this case, let's say perfect square, equals, the factorized form is going to be one set of brackets, all raised to the power of 2. Let's just say, for example, x plus a, all raised to the power of 2. Now, what does this mean in terms of graphing? So, again, now, a quote-unquote normal quadratic, we've got a Cartesian plane here. Two sets of brackets means two roots, and so it would look like this. But if we have a perfect square with one root, it just touches the x-axis, like that. Okay, and we could even use colour just to show this. So this is blue and green. Now, how are we going to find the value for m? Well, it's at this point we need to use our knowledge of discriminants. So the discriminant is b squared minus 4ac, And if we have a perfect square, that means one value for x, so one root, touches the x-axis once, and that means our discriminant is going to equal 0 here. Okay, and so we're going to substitute our values in. Our b term is m plus 1. That's squared minus 4. A term is 2m minus 1. And we're multiplying, and c is m minus 4. Okay, and that equals to 0. So let's expand these brackets. We've got m squared, and the b term is 2ab, so 2m plus 1 minus, and we'll keep the 4 as it is for now. And we'll say 2m squared. So I'm working on these sets of brackets here. And when I'm talking about expanding brackets as well, it's using the FOIL method, so multiplying first, outer, inner, and last. So we've got 2m squared, negative 8m minus 1m is going to be negative 9m, and positive 4. And this equals to 0. We've still got to multiply through by 4 here. So it's m squared plus 2m plus 1 minus 8m squared plus 36m minus 16 and equals to 0. We can collect like terms, so we've got terms with m squared, terms with m, and just our integer terms. So we end up with minus 7m squared plus 38m and minus 15. And this equals to 0. And at this point, we can use our quadratic solver. Interestingly, the marking schedule takes it to, they use a positive m squared term, so they basically change the operation of each of our terms. Let's just check if that matters when solving the quadratic. So let's use negative 7, positive 38, and negative 15. And we get values of 5 and, so up here, m equals 5 and 3 over 7. And those are the same answers as in the marking schedule where they use the quadratic 7m squared minus 38m plus 15. And I guess that makes sense because if you've got basically the two parabolas are the same, they're just orientated different ways, but their roots are the same like that. Okay, sweet. So values for m here. Oh, okay, we're not quite done. I'm just looking at the marking schedule. They say 3 over 7 eliminated as m minus 4 must be at least 0 since the expression is a perfect square. Interesting. So they say m does not equal 3 over 7 because m minus 4 must be at least 0. Okay, and what are they getting at with that? Basically, m minus 4 is our c term for the quadratic, and they're saying it has to be at least 0 because if we're talking about our perfect square theory, specifically the x plus a all squared, if we were to expand that, the c term would in that case be a squared. In any case, it would be greater than 0. So that's what they want. They want the c term to be greater than 0. And with m minus 4, if you were to substitute m equals 5 over 7 into that, you would get, and we can calculate it, 5 over 7 minus 4 is negative 23 over 7. So that's a negative number. If you substituted in m equals 5, 5 minus 4, that's 1. So m equals 5 only. Okay. Right. And that's because, again, since the expression is a perfect square, that c value will always be greater than 0. Okay, so now correct solution incorporating clear explanation of the rejection of m equals 3 over 7. We possibly haven't given a clear explanation here. If we had a bit more room, we'd write out some sentences explaining that. Anyways, let's say excellence for this question. Your merit comes from sets up the quadratic equation equal to 0. So this step here gets your merit, and achieved sets up the discriminant equal to 0. So this step gets you the achieved here. Okay, that's us for question 1c. Let's move on to question 1d now. It says, by factorising, find an expression in terms of p for the difference between the roots of the equation px all squared plus 4px minus 12. And again, we're finding an expression in terms of p for the difference between the roots. Okay. So we've got this equation here, px all squared plus 4px minus 12 equals 0. And so the first thing we need to do is decide what our roots are. You might see the px all squared and 4px in this equation and possibly jump straight to the quadratic formula. But let's expand our equation. We've got p squared x squared plus 4px minus 12, and it's something that we can just go ahead and factorise straight away. So we almost have to forget about the p squared and the 4p. Well, the p by itself. We need our 4x, obviously. But let's forget about the variable p altogether for a moment, and we need two numbers that multiply to negative 12 and add to 4. And those two values are going to be positive 6 and minus 2. So normally when we factorise this, we would have x plus 6 and x minus 2. But in expanding this, we would end up with x squared plus 4x minus 12. But we have, obviously, we've got our p squared, and we've got 4px in here as well. So we need to include in our factorised, inside our brackets, these values for p. And so looking at the a term, p squared x squared, well, to get x squared, all we had was x and x. So we are going to say px and px. And I think you'll find that that's all we need here. So we're going to say px plus 6 and px minus 2. And again, we could actually expand this again, and we'd come out with, hopefully, our original equation. So p squared x squared minus 2px plus 6px minus 12, and you see straight away that it's p squared x squared plus 4px minus 12. Okay, so that's our factorized equation. Still, we need to find the roots, so our roots are going to be x equals, looking at the first bracket, px plus 6, it's going to be minus 6 over p, just rearranging to solve for x there, and obviously this equals 0. It's going to be our second set of brackets, x equals positive 2 over p here. And so the question is asking for the difference between the roots. Difference between roots. Okay, so our two roots are minus 6 over p and 2 over p. So we're going to say, and it's something to think about, which way round to put the two roots. But it's talking about, the phrasing of the question is talking about difference between the roots. So you sort of just intuitively go larger number minus smaller number. So it's going to be 2 over p minus 6 over p. And so we've got our denominators are the same, so we can just go ahead and subtract. It's going to be minus makes it positive, so 2 over p plus 6 over p, it's going to be 8 over p. And so with that, we have found the difference between our roots here, and this actually gets you an excellence grade. Your merit is correct roots found, so merit up here, and achieved factorizes correctly or finds the difference between roots consistently. So factorizes correctly is what we're looking for there, for an achieved, so achieved up here. Okay, moving on to question 1e now. It says use algebra to show that the graph of the function y equals x minus a times x minus b minus c squared, where c does not equal 0, crosses the x-axis at two distinct points. Okay, so our function is y equals x minus a times x minus b minus c squared. And it says crosses the x-axis at two distinct points. Immediately we think of the discriminant here. We are going to be using the discriminant. So the discriminant b squared minus 4ac. If it crosses the x-axis at two distinct points, that means our discriminant is going to be greater than 0. And so what is our discriminant? We need values for a, b, and c here. And our function is in factorized form. So let's expand it. We're going to say y equals x squared minus bx minus ax plus ab and minus c squared. Still, we can tidy this up a little bit. Let's split it into terms with x squared, terms with x. So we've got this minus bx minus ax. So we are going to take x as a common factor, so positive x. And then it becomes, inside the brackets, let's say minus b minus a. And for the c value, it actually becomes a, b minus c squared. And it's important not to get confused because we're working with the variables a, b, and c, and we've said our discriminant is b squared minus 4ac. It's crucial not to get confused. Obviously, the discriminant is not literally b squared minus 4ac in this case. That's just the theoretical discriminant. Anyway, we have values for a, b, and c. Our a value is 1. B value is minus b minus a. And the c value is ab minus c squared. And so let's go ahead and calculate our discriminant. B squared minus 4ac. And that equals, let's do it down here, minus b minus a all squared, minus 4 times a is 1, so we'll just forget about it. C is ab minus c squared. Okay, so let's expand our brackets. We've got b squared, and the b term is 2ab, so I want to say positive 2ab plus a squared minus 4ab plus 4c squared. We've got some like terms in here, our ab's, so we're going to say let's say a squared plus, not plus, rather minus 2ab, because 2ab minus 4ab is minus 2ab, plus b squared plus 4c squared. And at this point, you might switch off because it feels like there's nothing more to be done here. But actually, looking at the first 3 terms in this equation, a squared minus 2ab plus b squared, that is going to be, we can actually factorize that and say this is a minus b all squared plus 4c squared. And at this point, we're trying to prove that this discriminant is greater than 0, right? Let's think back to the earlier question where x plus a all squared, and we talked about the c term, m minus 4. We had to have that as greater than 0. So that's the c term. And what am I getting at here? Well, we knew that m minus 4 had to be greater than 0 because the a, basically the c term was a squared, right? That was our theoretical c term. Anything to the power of 2, anything squared, is going to be positive here. And so looking at our expression, a minus b all squared plus 4c squared, well, we know a minus b all squared is positive, and we can even write it. A minus b all squared is positive because it's a square number. And likewise, 4c squared, well, c squared is going to be positive, and you multiply it by 4, it's still going to be positive, so this is also positive. And so 2 positive numbers, let's say adding positive numbers means meaning the discriminant here is going to be greater than 0. We could even miss out this idea that we're talking about positive numbers and just say adding square numbers. Either way, our discriminant is going to be 0 here. And so grades-wise explains why the discriminant is greater than 0 and makes a correct conclusion that is going to get you the excellence grade. Okay, your merit finds discriminant in factored form. So let's say this step here gets your merit. Your achieved is function set up so that discriminant can be found. So I think expanding our original function, we've set it up so that the discriminant can be found, so achieved here. Okay, that's us for question 1. Let's move on to question 2 now. So question 2, it says simplify fully, leaving your answers with positive indices. The first one here is 9a squared b to the power of negative 4 all raised to the power of 0.5. So 9a squared b to the power of negative 4, and that's all raised to the power of 0.5. So each term here is raised to the power of 0.5. And what I mean by that is the first thing we're going to say is root 9. And where did that come from? Well, 0.5 as a power is the same as 1/2, and fractional indices, it's power over root. And so 1/2 is the same as saying square root. So we've got root 9 and then a, and it's powers on powers, so 2 times 0.5, and that's the same for b as well, negative 4 times 0.5. So let's just tidy this all up. We've got 3a times, a, and then 2 times 0.5 is just 1, and b, negative 4 times 0.5 is b to the power of minus 2. Question says leave your answers with positive indices, and so we have to say 3a over b squared, because negative and negative power, if you flip it, basically in this case we're taking b to the denominator, then that power becomes a positive. Okay. Our second expression here, 2a over 3b4 all raised to the power of negative 2. So 2a over 3b to the power of 4 all raised to the power of negative 2. Well, the first thing I want to do is actually flip our fraction and make this negative 2 a positive. So we are going to say 3b4 over 2a is raised to the power of positive 2 now. And so it's just a matter of working through it. Same principles as before. We've got 3 squared times b to the power of 4 times 2. 4 times 2. This is over 2 squared to the power of a, and it's got an invisible 1 for a power, and that's times 2. And so we've got 9 b to the power of 8 over 2a, and is that, I believe that's as far as we can go here. Yep, so grades wise, correct answer gets you an achieved, and I think I forgot to do the grades for the first one. Again, correct answer just gets you an achieved here. Okay. Question 2b would be asked to write 2c plus 1 over c squared minus 9 plus c minus 2 over c squared minus 4c plus 3 as a single fraction in its simplest terms. So a single fraction in its simplest terms. Let's write out our expression. 2c plus 1 over c squared minus 9 plus c minus 2 over c squared minus 4c plus 3. And so you could go ahead and cross multiply here, but that would be incredibly difficult and long, and your denominators especially would get quite messy. We can actually factorize here. So we can say 2c plus 1, we can factorize our denominators. C squared minus 9, that's a difference between squares. So it becomes c plus 3 times c minus 3. And our second fraction, it's going to be c minus 2, and factorising this quadratic on the bottom, it's going to be c minus 1 and c minus 3. And so we're talking about combining these two fractions into a single fraction. Well, if we're adding the fractions, that means we need our denominators to be the same. And so our denominators are already similar. This first fraction, our denominator is c plus 3 and c minus 3. For our second one, c minus 1 and c minus 3. There's one common between the two of them, c minus 3, and they both have one difference, c plus 3 and c minus 1 respectively. Let's multiply. We can actually multiply these fractions and make them have a common denominator. So let's just go ahead and do it. I'll show it to you. For the left side, the left fraction, or the first one, we are going to multiply it by c minus 1. So what we do to the top, we have to do to the bottom. So c minus 1, and that's being multiplied. For our second fraction, we are going to multiply it by c plus 3. Okay, and so let's go ahead and do this. We've got 2c squared plus c minus 2c is, I believe, minus c, and minus 1. And this is looking at our second numerator now, c minus 2 times c plus 3. It's going to be c squared plus 3c minus 2c, so positive c, minus 6. And we'll say this is all over, because our denominators are the same. It's going to be c minus 1, c plus 3, and c minus 3. Okay, I hope that makes some sense. We can collect like terms on the numerator. We've got our c squareds, our c's, and our integers. So we end up with 3c squared. The c's cancel out, and minus 1 minus 6 is minus 7, and this is all over c minus 1, c plus 3, c minus 3, and there's no real need to expand these brackets. We can just keep them in factored form. And here, believe it or not, is the correct simplification, and that gets you a merit. Achieved cross arrangement to a single fraction. So I guess in here somewhere it gets you the achieved. Okay, moving on to question 2c now. It says factorise fully fm minus 6gn plus 3fn minus 2gm. We've got fm minus 6gn plus 3fn minus 2gm. And so they're asking us to factorise fully. We've sort of got, well, how many variables have we got here? We've got m, g, n, and f. We've got 4 different variables. But we can see some similarities between terms here. If we were trying to factorize a quadratic with 4 terms, so we had this is our quadratic, and the b value was split up into 2 parts, and we had our c term, we would draw our line and factorize the left-hand side, factorize the right-hand side, and go from there. Okay, and so we're going to be using the same principles, but if I wanted to look at factorize the left-hand side, fm minus 6gn, well, there's no common factors here, so we have to rearrange. And we're going to rearrange like this, fm, and we're going to say plus 3 fn minus 6gn minus 2gm. And now we've got some common factors. So looking at our left-hand side, or the first 2 terms, common factor of f, and then m plus 3n inside the brackets. Our last 2 terms, common factor of not -6 but -2, and we've got 3, and have I got my numbers right? 2, that's right, 2gm, not 2m, 2gm. So that makes our common factor minus 2g. And so we've got 3n plus m inside the brackets. And you'll notice, and this is what we say about factorizing quadratics as well, our 2 sets of brackets are the same here. So that means f minus 2g is a factor, and m plus 3n is a factor. And that is our correct factorization here. And it gets you a merit grade. Okay, your achieved is pairs factored, so basically the step here gets you an achieved. Sweet. Moving on to question 2D. It says the shape below is divided into rectangles. All measurements are in centimetres. This diagram has been corrected from that used in the examination. So I think in 2019 there were some issues with this question actually. Anyway, it says the shaded rectangle has an area of 9 centimetres squared. Obviously we've got this diagram here. We've got some dimensions, y plus 2, y minus 8, x minus 4, x and y. And it says find the area of the rectangle ABCD. Okay, so the key information here is that we know that the area of the shaded rectangle is 9. And so we're going to use that to help us with our variables here. So area of any shape is, and we could even say this first of all, area of a rectangle, because we're talking about, not any shape, but rectangles. Any shape in this diagram is going to be base times height. Okay. Area of the shaded rectangle, that's going to be base times height. And so what are our dimensions? Base times height. This is our shaded rectangle in here. It's going to have y as its height, and its base is y minus 8, okay? So y times y minus 8 is the expression for the area, and that equals, we know it equals 9, and so we can actually solve for y here. We've got y squared minus 8y equals 9, and so y squared minus 8y minus 9 equals 0. we can solve this on our calculator. It's a pretty easy quadratic. We've got a value is 1, b value is -8, and c value is -9. And so we get values of y equals 9 and -1, but we're working with, basically we're working to a context here, so we've got some constraints. You can't have a side length of -1, so only value is y equals 9, then we're going to say y can't be negative. Okay, and so how does this help us? Y equals 9. Well, we're trying to find the area of the rectangle ABCD. What are the dimensions for that area? We could probably bring it down a little bit. Area of ABCD. We can have a look at our diagram here. ABCD, so that is that's this shape, and we've got dimensions of x minus 4 and x here, x minus 4 and x. So let's just jot that down, x times x minus 4. Now that doesn't actually help us because we have found the value for y, and so we want to be working in terms of y here. And so basically the key is just playing around with our diagram. You'll notice that, and what color should I use? Let's use, what color should I use? Let's just use black to show it. This x, this length here, is the same as the y minus 8 and y minus 2 length. It's the same length, top and bottom of the shape. We can say x equals y minus 8 plus y plus 2 here. And so that, just collecting like terms, we've got 2y minus 8 plus 2 is minus 6. So x equals 2y minus 6 here. And let's bring that back down into our equation. So x equals 2y minus 6. So we can say 2y minus 6. And then we've got 2y minus 6 minus 4. And so we just simplifying this, we've got 2y minus 6 times 2y minus 10. And so we could expand this. We've got 4y squared minus 20y minus 12y is minus 32y, and plus 60. And so at this point, we are going to we're going to substitute our value for y, which is 9, into our equation. So wherever we see y, we're going to use the value 9. So 4 times 9 squared minus 32 times 9 plus 60. Okay, so what have we got? 4 times 81 is 324, minus 32 times 9, and I'm just calculating these, 288, plus 60. So adding all these terms up, we've got 324 minus 288 plus 60, and that equals 96 here. 96 centimeters squared. And so with that, we have found the area. Area equals 96, and this gets you an excellence grade. Interestingly, no merit criteria for this question. But if you found the value for y, so y equals 9, you'd get an achieved mark. Okay, moving on to question 2e now. So question 2e, it says one root of the equation x squared plus px plus q equals 0 is n times the other, where n does not equal 0. Show that qn squared plus 2q minus p squared times n plus q equals 0. So we've got this equation here, x squared plus px plus q equals 0. And the first thing we have to do is decide what our roots are. And I think the only way we can do this is by using the quadratic equation. So straight ahead, we're going to go straight ahead and find our roots using the quadratic equation. Minus b plus or minus the square root of b squared minus 4ac, and this is over 2a. So substituting in our values, we've got minus p plus or minus the square root of p squared minus 4. Now a is 1, so we'll just forget about it. C is q, so 4q. And 2a is just 2. So here we actually have two solutions for x, and we have two solutions because we've got this plus or minus in here. So our first solution is x equals minus p plus the square root of p squared minus 4ac over 2. And the second solution, x equals minus p minus the square root of, not b squared, but p squared minus 4, and actually I've made the same mistake over here, haven't I? Not ac, it's 4q, and 4q as well. And this is over 2. Okay, and so it says one root of the equation is n times the other. So if we wanted to make them equal each other, we could say minus p plus root of p squared minus 4q over 2 equals n times our second root, which is minus p squared minus 4q over 2. Okay, and so they're asking us to show that this is true here. Qn squared plus 2q minus p squared n plus q equals 0. So we're just going to be doing some rearranging here. And I forgot these brackets as well. These is inside brackets. The first thing we can do is cancel our 2's. So they're both being divided. Means they cancel. And we're left with, let's say, minus p plus the square root of p squared minus 4q. And let's multiply through by n on this right-hand side. So minus np. Or should we say Pn minus n times square root p squared minus 4q. Hopefully that makes sense. And this is not over 2. Okay, so we've got this equation here. You'll notice that we've got some basically similar terms. So we've got this minus p and minus pn. And we've got the root p squared minus 4q. And so let's bring these similar terms to the same side. We could say, let's say root of p squared minus 4q plus n times root of p squared minus 4q. This equals, and we'll say p minus p times n on our right hand side. Okay, so, and again, we're just trying to tidy up our equation as much as possible. We can factorize on both sides. We could say we've got a common factor of root p squared minus 4q, and inside the brackets you'll get 1 plus n. On our right hand side, we've got a common factor of p, inside the brackets 1 minus n. Okay. At this point, let's go back up to our equation or expression that we're working towards, and you'll notice that there is no square root p squared minus 4q in this equation. So the next thing we can try to do is get rid of our square root p squared minus 4q. And so to do that, let's isolate it, make it the subject. So we could say root of p squared minus 4q, and we'll bring our 1 plus n to the right hand side. So p times 1 minus n over 1 plus n. At this point, what's the opposite of square root? It's squaring, so let's square both sides now. And so we've got p squared minus 4q, and we have to square our right hand side, so p squared, and this 1 minus n we could basically say is times itself. So let's write that. We've got 1, and the b term is 2ab, so 2n plus n squared. It's inside brackets. On the denominator, we've got 1 plus 2n plus n squared. Okay. Let's keep going. Let's take our 1 plus 2n plus n squared to the left-hand side. And so we end up with let's write p squared first. P squared minus 4q times 1 plus 2n plus n squared. And we're hoping near the end of it that we will have some terms to cancel out. This equals, and let's multiply through by p squared on our right hand side, so it's p squared plus, now is it plus or is it minus? Sorry, the b term is 2ab, so that's minus 2n, so it becomes p squared minus 2np and plus p squared n squared. Okay, we can expand the brackets on our left-hand side, working with the p squared first of all. We've got p squared plus 2 np squared, and I've just made a small mistake on our right-hand side. This 2np, that should be 2np squared, shouldn't it? Okay, plus p squared n squared. Okay, so that's our p squared done. Now let's look at the 4q. So we've got minus 4q, and I'm going to run out of room here, minus 8 qn minus 4q n squared, and that equals p squared minus 2np squared plus p squared n squared. Okay, and illustrating this is our 4q answers. Okay, obviously our right hand side has remained unchanged. How much room have we got here? Okay, so we're just continuing on. As mentioned, there are some terms we can cancel. we can cancel the p squareds, the p squared n squared. Oh, apologies. Where are we? So the p squared n squared goes, and anything else? The 2np squareds are like terms. They've got different operations on different sides of the equal sign, so they don't cancel, but we can collect like terms. So 2np squared plus 2np squared, bringing it all to the left, we've got 4np squared. And I think we just write everything else out. 4q minus 4q, that is, minus 8qn minus 4qn squared, and I'm hoping that is our simplifying is correct here. Let's go back up to our model sort of answer, or I'll show that equation, and they've sort of, you'll notice they've written it in basically n squared plus n plus q form, similar to ax squared plus bx plus c equals 0. And so that's, I think that's what we're working towards here. So looking for our n squared terms, yep, we've got 4qn squared. Now our terms with n in them, we've got positive 4np squared minus 8qn minus 4q. This equals to 0. Again, let's go up to the top. I have noticed that we can take a common factor of 4 here, and actually let's do that now. So we're taking out a common factor of 4, that will just cancel because we're dividing by 0. So straight away we can write qn squared plus np squared minus 2qn minus q. Okay, now let's compare. I believe we have to work with our two middle terms. What have we got? Okay, so they've got qn squared plus 2q minus p squared n plus q. Okay, let's look at that qn squared and q. Let's just make sure. Now I've got, is this negative? Yeah, it should be negative. So we've got negative qn squared and negative q. They've got positive qn squared and positive q. Okay, that's not too much of an issue. We can add the two middle terms now. They've got 2q minus p squared with n as a common factor. 2q minus p squared, so I'm just looking at this part. And that will work. Our operations are the wrong way around, so we can basically divide by 1 here. Sorry, divide by negative 1. Or you could think of it as taking everything to the opposite side of the equal sign. Anyway, we can just change the operation. That is legal. So qn squared minus np squared, and actually at the same time let's take n as a common factor, so minus n, and we could say positive n here, positive n, and then you've got, it'll be minus p squared plus 2q. Hopefully that makes sense. And then positive q equals 0, and I think that is it, isn't it? We've got minus p squared plus 2q. They've got 2q minus p squared. Okay, so their brackets are the other way around. We can do that. So they've got 2q minus p squared with n as a common factor, and plus q equals 0. And with that we have we've shown it here. Okay, so finds correct equation with correct algebraic working. This gets you your excellence grade here. Successfully squares both sides is your merit. So squares both sides. I think we did that a while ago. It's a big excellence question. We did that here, so merit, and you achieved one root is n times the other. So just setting up the equation would get you the achieved, so the step here. Okay, that's us for question 2. Let's move on to question 3. So question 3, it says find the value of m if log 5m minus 3 equals 0. So, okay, so log 5 is our base, m 3 equals 0, and we have to use our log rules. And what have we got here? We could say log 5m equals 3. Is that valid? Hopefully it is. I'm assuming that minus 3 is not part of the log 5m. Otherwise they would have it in brackets, the m minus 3. So yeah, now we can say 5 to the power of 3 equals m. So this is our log rules. And so therefore m equals, this is 125. Okay. Correct answer here. M equals 125 gets you an achieved. Right is a single logarithm. This is question 3b. Log 6 minus 2 log y. Log 6 minus 2 log y. We can assume the bases are the same. And so here we are subtracting logs. So if we want to combine it into one log, we end up with basically dividing what goes inside the brackets. So it's going to be 6 over, and our log rules, we know that x log, let's say x log a, I don't know what variables they use, that can equal log a to the power of x. And so I'm going to say this is log 6 over y squared, is what I'm getting at. Log 6 over y squared inside the brackets. And this is your final answer here, so achieve for this. Okay. Question 3c, it says fully simplify this fraction, 3 to the power of 2n minus 1 plus 3 to the power of 2n plus 1 over 3 to the power of 2n minus 9 to the power of n minus 2. Okay, 3 to the power of 2n minus 1. Let's just write out our expression. Okay, this is over 3 to the power of 2n minus 9 to the power of n minus 2. I think there's probably a few different ways you could go about this. Definitely something we are going to do is rewrite our 9 as 3 to the power of 2. So we always want our numbers to be having the same base when we're working with these indices questions. So let's rewrite this as 3 to the power of 2n minus 1 plus 3 to the power of 2n plus 1 over 3 to the power of 2n, and then minus 3 to the power of 2. And we've got powers on powers here because it looks like this, 3 to the power of 2 raised to the power of 2n plus 1. Now I don't want to spend a step writing that out, so we're going to say 3 to the power of 4n plus 2. So we've multiplied, basically we've multiplied 2n plus 1 by, now it wasn't 2n plus 1, is it? It was n minus 2, my mistake. Yeah, my mistake. We're working with this here, so it's not going to be 4n plus 2. Rather, it's going to be n minus 2 times 2. Again, powers on powers, so that is going to equal 2n minus 4. Okay, so let's just tidy this up. 2n minus 4. Okay, we got there in the end. Now, how do we make progress? Well, we're going to factorize So our numerator, and this is typical of algebra questions. When you've got fractions, you look to factorize, and hopefully they cancel, common factors cancel on top and bottom. And that's sort of how you go about simplifying. Basically, looking at our numerator, we can say we've got a common factor of 3 to the power of 2n. 3 to the power of 2n. And then inside the brackets, it's going to be 3 to the power of minus 1. Now, why is that true? Well, if we were to multiply these two, you don't multiply 3 by 3 equals 9. You say it combines into one term, and it's 3, and the indices are added because we're multiplying, so it becomes 2n plus minus 1, and that equals, obviously, 3 to the power of 2n minus 1. So that's the logic here. Okay, we can just delete these brackets for a moment. So that's this. That was that first term, so this one here. And so we're going to get plus 3 to the power of positive 1 for our second term. That goes inside the brackets. So that's our numerator. Our denominator, common factor of 3 to the power of 2n again. Inside the brackets, it's just now you could say 1, because all it is 3 to the power of 2n. This is the first term. You could say 1, you could say 3 to the power of 0. And let's even write that, 3 to the power of 0 equals 1. And then you've got 3 to the power of minus 4. Okay, I hope that makes sense. So, 3 to the power of 2n cancels, meaning we're left with basically we've got, and we can actually simplify here, so 3 to the power of negative 1. Now, how are we going to do that? Let's just write it out and we'll see what happens. 3 to the power of negative 1 plus 3 to the power of 1. 3 to the power of 0 is 1, minus 3 to the power of negative 4. Okay, so we can just calculate this. 3 to the power of negative 1. That is 1/3. So basically it's 1/3 plus 3 over 3 to the power of negative 4. What is that? 3 to the power of negative 4. 1 over 81. So 1 minus 1 over 81. And so we're just going to calculate this. I'm hoping it simplifies to a reasonable answer. So let's go 1/3 plus 3 over 1 minus 1 over 81. What does that equal? It equals 27 over 8. 27 over 8. And I'm looking at that marking schedule, and yep, that is the correct answer. So correct answer here gets you actually an excellence grade. Your achieved finds common factor of the numerator and denominator, so the step here. Did I say achieved or merit? This is your merit grade here. And your achieved is correct answer only. Okay, so yeah, it's probably something that you could calculate pretty early on. We've shown it algebraically. If you got the correct answer only, that will get you an achieved. Let's just say correct answer only. Okay. So let's move on now to question 3DI. It says the number of people in suffering from a contagious virus increases exponentially at a constant rate of 5.3% each week after the virus was initially diagnosed. If n subscript 0 is the number of people initially diagnosed, okay, then t weeks after the virus was initially Sorry, let me reread that. Is the number of people initially diagnosed with the virus, then T weeks after the virus was initially diagnosed, okay? N can be modelled by the function N equals N initial times 1.053 to the power of T. How long will it take for the number of people diagnosed with the virus to be 3 times the number initially diagnosed? Right, so we've got this formula, N equals N0 times 1.053 to the power of T. Okay, so we're just going to be substituting some values in. The key to the question that will help us make progress is this idea that how long will it take? So we're finding T for the number of people diagnosed with the virus to be 3 times the initial. So 3 times the initial. Well, the initial is N 0 like this. 3 times the initial is going to be obviously 3 N 0. And actually this is basically N. So we can substitute that in. We've got 3 N0 equals N0 times 1.053 to the power of T. Is there any other information that we need? Constant rate of 5.3% per week. That's that 1.053. I think from here, we're just going to go ahead and solve. The first thing we can do is actually cancel in subscript 0. So that's actually a variable here. So we can cancel that on both sides. We end up with 3 equals 1.053 to the power of T. And we've just been dealing with logs, and we're going to continue dealing with logs. So we can take log of both sides. So log 3 equals, and we're going to say T times log, this is that power rule again, T times log 1.053, and we're trying to find T, and so T must equal log 3 over log 1.053. Okay, that's our formula. So we can go ahead and calculate this. We've got log 3 over log of 1.053, and that comes out as 21.27. So just looking at the context of the question, T is weeks after the virus was initially diagnosed. And so here our answer is 21.27 weeks is what we're looking for, and this gets you a merit grade. Your achieved is taking log of both sides and T as a factor. So this step here would get you an achieved. Sweet. Moving on to question 3D2. And so that asks, the number of people N suffering from a different virus also increases exponentially at a constant rate R% each week. 2,500 people initially diagnosed. After 10 weeks, the number of people suffering had increased to 4,250. Find R, so rate, percentage, assuming the form of the model in part 1 still applies. So that, what was that model? It was N equals N to the power of 0 times, now they had 1.053. But here we don't have a rate. Remembering that the 1.053 represented the rate. And we know that because basically the generalized formula for compounding is basically amount equals principal times rate to the power of time. Okay, So we need rate, and actually that's what we're finding in the question, and that's to the power of t. Okay, so what are we going to do here? We have to substitute in some values. 2,500 people initially diagnosed. After 10 weeks, number of people suffering had increased to 4,250. So we could say N equals 4,250. N subscript 0 was the initial, so 2,500. And time after 10 weeks, well, t equals 10 is what I'm getting at. So let's substitute these values in. We've got 4,250 equals 2,500 r to the power of 10. Okay. And so here, and is that correct? Yeah, okay, we can work with that. First thing we're going to do is divide 4,250 by 2,500. That equals 1.7. 1.7 equals r to the power of 10. And so we could take the 10th root of 1.7. 10th root. And that would equal r. And let's do that. So you have to find the correct button on the calculator, and I'm searching for it. Okay, shift. Okay, and then 10, 1.7, that equals, the 10th root of 1.7 equals 1.054. 0.545, we could say. That equals r. And so they're asking us to, yeah, we're not quite done. We have to give it as a percentage. Remembering that with 1.053 in the earlier question, the percentage was, and if we scroll back up, the percentage was 5.3%. So basically the percentage here is going to be 5.45%. Okay. So here, percentage rate of change found gets you the excellence grade. Your merit, it says finds 1 plus r over 100. That is our, basically, I think that's possibly this step here gets you a merit. And you're achieved sets up the correct equation, so this here gets you the achieved. Sweet. Moving on to question 3E now, the last question of the paper. It says the Golden Gate Bridge in San Francisco has 2 towers. The height h in meters of the suspension cables above the mean water level at a horizontal distance x meters from the base of the left tower can be modelled by the function h equals k x minus 640 all squared plus 67. Okay, at the midpoint between the 2 towers, the suspension cables are 67 meters above the mean water level. The distance between the towers is 1280 meters. Towers are 227 meters tall, measured from the mean water level. Okay. And we've been given a nice picture. We've got a diagram. It's our diagram here. I'm assuming that when it says 67 meters, that's this length here at the minimum. 67 meters. I'm hoping. Okay, what is that word? An anemometer shown as A in the left-hand diagram above to measure wind speed is placed on a cable at a height of 100 meters above the mean water level. So that's A here. find the horizontal distance of the anemometer from the left tower. So we're trying to find, let's call it x here, this distance here is what we're trying to find. Okay, so what is our equation? Let's just work with that. Our equation is h equals k x minus 640 all squared plus 67. So h equals k x minus 640 all squared plus 67. The first thing we have to do in these sorts of questions is find a value for k, because k is a constant, and so we need to take any point and substitute it in for, now I would normally say x and y, in this case it's x and h. So we can decide any point that's been given to us. So let's say it is, let's take this point here. Okay, and the coordinates at that point are basically 1280 is the x change, and the height is 227, 280, 227. H equals and x equals at that point. So let's substitute these values into our equation, and we're going to find k from there. So we can say, what was it, 227 equals k, and then x was 1280 minus 640 all squared plus 67. We could rearrange for k. Let's just tidy this up a little bit. We've got, okay, what is 1280 minus 640? That equals 640. Let's square it. It's a nasty number, 409,000. So it's 227 equals k, 409,600 plus 67, and actually this is being multiplied, isn't it? Okay, we're trying to get k on its own. We can take the 67 to the left hand side. 227 minus 67 is 160, and so k equals 160 over 400 and this number 409,600. Okay. Now what is that? 409,600, or you could say 640 squared. That is this number 3.90625. Calculator gives it in standard form, times 10 to the negative 4. Okay? And so that's our value for k. And with that, they're asking for, the question is asking for the horizontal distance. So, as mentioned, we're trying to find x. We're trying to find x where h is 100. Okay, and so let's write that. We've got, we're trying to find x, so let's say h, but we've been given h, haven't we? So 3.90625, and it probably would be better to rearrange before plugging the numbers in, but that's all right. Equals, no, this is k, my mistake. This is k, and so h is 100. So 100 equals k times x minus 640 squared plus 67. This is our equation here, and we're solving for x. So let's take the 67 to the left-hand side. 100 minus 67, that is 33, and we'll divide it by the value for k, 3.90625 times 10 to the negative 4. That equals 84,480. I'm hoping that's correct. 84,480. 100 minus 67, yep. Divide by that. Okay, yep. That equals x minus 640 all squared. Let's square root the 84,000. So square root of answer is 16 root 330, which is 290.65 equals x minus 640. And so we're going to add 640. That equals 930.65. 930.65 equals x. Now the marking schedule mentions another value, 349, and I think they get that from basically when we took the square root, and I missed this, square root of 84,000, you get a plus or minus 290, right? So this is, we just worked with the positive 290. What about minus 290.65 plus 640? That'll give us another value for x. That equals x, and that equals, what do we have? Minus 290.65 plus 640. That equals 349.35. 349.35. Okay. So these are our two values for x, 930 and 349. We can only have one value for x, obviously. So if we go back to the question and look at what's going on here, we've got basically, so this height of 100 appears twice on the parabola. So if we draw a horizontal line, it also appears here. So we are looking for the lesser of the two x values. So this is 349. And the second point would be the 930. And that makes pretty good sense just looking at the spacings. Obviously the total is 1280. So here x equals 349. So we go down here and we say, let's just say x equals 349. What was it? 35. And that is our answer here. Okay, so correct answer gets you an excellence grade. Your achieved finds the value k, or you've gone on to find consistent solutions from an incorrect k. So assuming you went ahead and did everything correctly, finding the value for k gets you a merit here. There we go, merit. Okay, got there in the end. We got there in the end. So that's the paper. I hope you guys enjoyed. A long paper, a difficult one, some longer excellence questions there. And so it'll be a long recording, I'm sure. Either way, guys, I hope you enjoyed. And I will see you next time. Cheers.